Alright guys, in this video we're going to focus on the weak acids. Take a look at this concept map. And the red part is weak acids and the blue part is the weak base. And in the middle of this concept map, it shows us the connection between the weak acid and weak base. And more specifically, it tells us the relationship between the Ka and the Kb and the pKa and the pKb. Okay, so let's try this example and see how we find out the hydronium concentration and pH value for a weak acid. Alright, now in order to find out the pH value and the hydronium concentration for a weak acid, you do have to take a look at the equilibrium created by this weak acid. So the first step is to write down the equilibrium equation for this weak acid. So you dissolve this acid in water. It's gonna, since now we know it's an acid, so it's gonna be a proton donor. So that's okay. That means that it's gonna lose one proton to give you conjugate base, which is negatively charged, and water is going to accept one proton to become hydronium. Okay, so now we know since it's an acid, it has to generate hydronium cation. Alright, now how do we use this equation? How do we use the Ka value to find out the concentration of hydronium? Here's the thing. By having this equation, you can start the construction of the IC charts: initial concentration, charge, equilibrium concentration. So initial concentration of this acid is 0.150, and the initial concentration for the other two products would be 0 and 0. And let's assume that X mole per liter of this weak acid dissociate. So minus X for the weak acid, and meanwhile, because it's 1 to 1 to 1 ratio, X mole per liter of this conjugate base and X mole per liter of the hydronium will be generated. So this is a change. And then based on these two rows, you can express the equilibrium concentrations for the three species. For the weak acid, that is 0.150 minus X, and the two products would be X and X. Okay, so this is the first step. Then the second step is to express the equilibrium concentration or equilibrium constant for this weak acid. Second step, so Ka. That equals to the conjugate base concentration times the hydronium concentration over the concentration of this weak acid. OH, C4, H7, O2. Now, since we've already expressed the equilibrium concentrations for three species, so you just plug them in. X times X equals to over 0.150. 0.150 minus X. And now let's think about it, because the equilibrium constant is quite small, 1.5 times 10 to the negative 5. So X, the value of X would be very small because only part of this weak acid will dissociate. Okay, so when you use this large number minus a very small number, so we can make the assumption that this bottom part equals to 0.150 itself. So the equation would be much simpler. Like I show you here, the bottom part would be just 0.150 itself. Now solve X. Okay, solve X, and that equals to 0.0015 mole per liter. Okay, and now let's validate this assumption. Okay, the assumption we made a moment ago says that x is very small. Let's just validate that. So the next step is, let's take the ratio between x and the original initial concentration of this weak acid, that is 0.150 mole per liter, and you multiply by 100%. So essentially we are looking at the percentage ratio between the x and the initial concentration, and that is about 1.0%. If this percentage ratio is less than 5%, then we say that this assumption is okay. If this is larger than 5%, then this assumption is not good. Then you do have to go through the quadratic equation to find out x. And in our example here today, since the 1.0% is less than 5%, so our assumption is good. Now let's go to the last step. Okay, so we need to find out the concentration of hydronium and the pH value. So the step 4. Remember, since we know x is equals to equilibrium concentrations of hydronium, so the value of x is the concentration of hydronium, and that is 0.0015 mole per liter. Now the pH value would be just the negative logarithm of this hydronium concentration. Okay, that equals to 2.82. This is how we find out the pH value and hydronium concentration for weak acid. Again, you do have to know how to construct the IC chart here, express the equilibrium constant for this weak acid, make the assumption, validate the assumption, and confirm the hydronium concentration, and then get the pH value. So hopefully this one will help you understand how we find out the pH and pH value for weak acid. And again, let me know if you have any questions.